Let us master the CBSE Class 10th Science Chapter 11 Electricity. What is electric current? We know that electrons flow through a conductor. The rate of flow of these charges across any cross section of a conductor is called electric current. It is given by Q by T, where Q is the charge and T is the time. So the definition would be rate of flow of net charge across any cross section of a conductor, and the formula of current is I is equal to Q by T. The SI unit of current is ampere, represented by a capital A, and it is measured using an ammeter. The other units of current which are used are milliampere, which is 10 to the power minus 3 amperes, and microampere, which is 10 to the power minus 6 amperes. 1 ampere of current is defined as the flow of 1 coulomb of charge per 1 second in a conductor. What is electrical potential difference? Well, let us consider a pipe with water in it. If the pipe is horizontal, the water will not move across the pipe. For the water to flow, we need to tilt the pipe to create a difference in potential or pressure due to gravity and make the water flow. Similarly, the charges in a conductor do not flow as such. We need to create a pressure difference, or in this case called a potential difference, for the electrons to flow. If we keep two plates of a conducting material and collect all the charges on one plate, we have done some work in moving all these charges to one position. So this work done to move a unit charge from one point to another is called the electric potential. Now, because there are more electrons on this side, there is a potential difference between one plate and another which cause the electrons to move across. This potential difference is given by work done by charge, which is V is equal to W by Q. The SI unit of measurement is volt, represented by a capital V, and it is measured using the voltmeter device. The flow of current is always taken from positive terminal to the negative terminal of a cell. So 1 volt is basically 1 joule of work done to move a charge of 1 coulomb from one point to another. We generally have a lot of elements in a circuit diagram. Instead of representing it as such, we use symbols to represent the electric circuit conventionally. So the conventional symbols of an electric cell, a battery, a plug which is closed and open, a wire joint, a wire crossing without joining, an electric bulb, a resistor, a variable resistor, an ammeter and voltmeter are as follows. We will use these symbols in our circuit diagrams to show different elements as discussed. Ohm's law. Now let us perform an experiment to understand what Ohm's law is. In this given circuit, we will be measuring the potential difference across the points X and Y and the current passing through it. We will be increasing the number of cells in the circuit as we go ahead and note down the different voltmeter and ammeter readings to see the increase or decrease in the voltage and current. So let us say we used one cell, the voltmeter reading was 5 volt and the ammeter reading was 2 ampere. The ratio V by I will be 2.5. If we increase the number of cells to 2, the voltmeter reading was 10 volt and the ammeter reading was 4 ampere, giving rise to same ratio of V by I, which is 2.5. Adding another set of cells of 3, the voltmeter reading is 15 volt and the ammeter reading is 6 ampere. Again, the ratio remains constant at 2.5. Now increasing it one more time to number of cells used as 4, voltmeter reading is 20 volt and the ammeter reading is 8 ampere. The V by I ratio still remains a constant at 2.5. If we plot the V and I in a graph, we get a straight line passing through the origin. This explains that the ratio V by I is always a constant. And this relates to V is proportional to I. If we remove the proportionality constant, we can write V is equal to IR, where R is the resistance and it is a constant at a given temperature for a given metallic wire. This proposed the Ohm's law, which states that the potential difference across the ends of a metallic wire in an electric circuit is directly proportional to the current flowing through it, provided the temperature remains same. This gives rise to the famous Ohm's law formula V is equal to IR. Let us understand resistance in clarity. Resistance is an ability of a metallic wire to restrict the flow of electrons. It is used in circuits to reduce the current flow or increase the voltage as per the need. The SI unit of resistance is ohms, given by the symbol as such. The definition of 1 ohm is if potential difference across two ends of a conductor is 1 volt and the current through it is 1 ampere, then the resistance of the conductor is 1 ohm. Let us see what are all the factors that affect the resistance. Well, you have to restrict the flow of electrons. So if we consider the resistor as a pipe, what would affect the flow of water in this pipe? Well, if we increase the length of the pipe, it would take more time to flow. And if we reduce the diameter of the pipe, which is reducing the area of cross section, that would also affect the flow of water. Similarly, for a resistor, the length of the resistor is directly proportional to its resistance. That is, longer the length, higher the resistance. And the diameter or area of cross section is inversely proportional to the resistance. That is, more area of cross section, faster the electrons will flow, which is lesser the resistance. So combining these two, we can write R is proportional to L by A. And removing the proportionality constant, we can apply rho, which is the constant of resistivity, which is same for given temperature, and it is the characteristic property of the material to allow the flow of electrons. This resistivity will be very high for insulators and moderately low for conductors. The SI unit of resistivity is ohm meter. System of resistors. When more than one resistor is present in a circuit, the effective resistance of the circuit can be varied based on how they are connected. So to calculate the effective resistance, let us see the two possible kind of connecting more than two resistors. When the resistors are connected end to end, they are said to be in series. And if they are connected parallelly to each other, they are said to be in parallel. So when they are connected in series, the current through them remains same, but each resistor has a different potential difference. So applying Ohm's law on this, total voltage across all the three resistors would be V1 plus V2 plus V3. Applying Ohm's law, where V is equal to IR, IR would be equal to IR1, IR2 and IR3, where R is the total effective resistance. Removing the I from this equation, we can write the effective resistance when connected in series as R1 plus R2 plus R3. Similarly, when the resistors are connected in parallel, the current across them is different, but they all have the same potential difference across each other. So the current would be I1 plus I2 plus I3, and applying Ohm's law on this, V by R is equal to V by R1 plus V by R2 plus V by R3. And the effective resistance 1 by R would be equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the equivalent resistance when connected in parallel. So let us compare both the cases to understand this better. So if the resistance are connected in series, the current remains same, and when connected in parallel, there is different current across each resistor. The voltage is different across each resistor in series, and it remains the same when connected in parallel. The effective resistance in series is R equals to R1 plus R2 plus R3, and in parallel 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. The impact in the circuit when connected in series, the resistance reduces the current flow, and they are connected in parallel to ensure the same potential difference is maintained across the circuit. Let's see how we determine whether the resistors are connected in series or in parallel in a complex circuit as such. So start from the positive terminal of the cell, and as we know, we start drawing the current drawn. Where the current divides, those two sections are in parallel. So here the R1 and the above system are in parallel with each other. Now further, when the current passes through R2, it further again splits at R3 and R4, which signals that R3 and R4 are in parallel, and the equivalent of this is in series with R2. And the entire system is again in parallel with R1. So the direction of current determines if the resistors are in series or parallel. Always use the direction of current instead of following the logic of connected together or connected one below the other. This way you will never go wrong. Let us now see the heating effect of electric current. A battery or cells expends the energy to keep the flow of electrons in the circuit, where they keep doing the work to keep the charge on the one side. Now, most energy that is expensed is used for the electrons to move across the circuit, and some of it is lost as heat in the circuit, which is inevitable. So a purely resistive circuit is purely energy dissipated in the form of heat. If a current I is flowing through a resistor with a net potential difference of capital V, the work done to move the charge Q flowing across during this time t through this potential difference of V. So when an electron tries to move across from the positive and negative, the work done to move this charge during time t would be given by work done, which is equal to V into Q. So the power required to do this would be work done divided by time, which is VQ by T. We know that Q by T is current, so the power is nothing but V into I. So the heat energy which is dissipated would be power into time, which is Vi into T. Applying Ohm's law to this, we can write the heat dissipated is I square R T. The heating effect of an electric current is an inevitable process, and it is used in many applications such as toasters, kettles, room heaters, electric irons, and ovens. The most famous use of heating effect is an electric bulb which uses this heat to generate light. The filament of this bulb is made with a strong metal of tungsten which has a very high melting point, and it absorbs the heat generated and gets hot enough to emit light. The bulbs are filled with chemically inactive nitrogen and argon gases to prolong the life of the filament. Another use of this electric heat effect is electric fuse, which uses this to prevent any damage in the circuit. It is connected in series to the circuit, and it is made of a metal or alloy with appropriate melting point. Current larger than specified amount flows through the circuit. It will melt the fuse and break the circuit. What is electric power? Well, we have just seen the work done to move a charge flowing across during the time t through the potential difference of V is W equals to V into Q. This P would be equal to work done by time, which is VQ by T, and again the power is given by V into I. The power then applying Ohm's law would be I square R or V square by R. The SI unit of power is watt, represented by W. Another unit of power is kilowatt hour, which is nothing but 1000 watt, 3600 seconds, which is nothing but 3600 kilojoules. 1 watt is the power consumed by a device that carries 1 ampere of current when operated at a potential difference of 1 volt. Thank you for watching till the end of the video. Hope you have understood the concept and scored well in your quiz. Like and share this video. Comment on this video on what would you like to watch next. Subscribe to the channel and tap the bell icon for more such videos.